All right, next up here in question 4, we are trying to write sine and cosine functions being given just a graph with points, of course, on it. But let's attack that the same way I've looked at all these problems, step by step. First step, draw in that median line. See if I can do this with the computer pen. So that midline that I'm talking about goes, in this case, we've identified that midline with these points and these coordinates given here. But what's nice about drawing in the midline is it also helps visualize a few more things. So for starters, our first look is that the midline values, the -4 of that, the y value of these coordinates, that y is telling us that, see, the midline of sine and cosine should be the x-axis, but we're at -4. So what that tells me is my vertical shift is down 4. Better. And that midline helps us for a few other reasons. One of them being our amplitude. So if you look at our midline, we're at -4. If we look at a peak, we're at -2. We could also say from the midline, we're -4, to the valley, we're -6. But the distance from the midline to the peak is our amplitude. So our amplitude is magnitude 2. So let's start writing some of this out. So f of t is the amplitude A, sine of b times x minus c. Well, we're not quite there yet. We're not ready for b yet. So let's look at b. B, so I'm going to draw a line right here and right here. That distance between those two red lines I drew, that's the distance of the period of this graph. So from one peak to another, we've gotten one full cycle of our curve. So in that case, what I'm going to say is I've got 5 pi over 4 is this distance right here. And then what I have here, I have 3 pi over 4. So the distance from that y-axis over to the left to a peak, 5 pi over 4. From the y-axis to the right to my next peak is 3 pi over 4. When I combine those two and find the overall distance from one peak to another, that's 8 pi over 4, which reduces to 2 pi. So 2 pi is the period, so 2 pi equals, and then we say b is equal to 2 pi over b. Sorry, the period is equal to 2 pi over b. So in the end, b gets replaced. We kind of switch those two around, and we say b is equal to 1 in this case. So our equation is looking like 2 times sine of 1 times the quantity x minus c. We have our vertical shift, so -4. So our horizontal shift, and I just realized I did not have the same color, sorry about that. Our horizontal shift, well, we're writing a sine function first. And our sine function should start at the midline and be increasing. So that's right here, this point right here, that's where we should be starting. And we're not. We're starting the y-axis down here. So what you see is this distance over is pi over 4. That's our vertical, or sorry, that is our phase shift. So x minus pi over 4. So we've filled all of the requirements. 2 amplitude times sine of 1, which is the period referencing b, times x minus phase shift, pi over 4, minus the vertical shift 4. Now, when we do this for cosine, let's go blue. Cosine's not going to be any different for most of it, right? So f of t is equal to, the amplitude of cosine does not change. 2 cosine. The period of the graph doesn't change. X minus The phase shift is what changes. The vertical shift isn't affected. The difference between sine and cosine is just simply this left and right phase shift. So everything else, without doing any more work, can be copy and pasted. Now, at this point, we have two choices. We have a peak here, and cosine should be peaking right at the y-axis. So we can either call this a shift to the right of 3 pi over 4, which would be like x minus 3 pi over 4. We could instead say, no, I'm going to call this more of a phase shift to the left of 5 pi over 4. That would just simply say x plus 5 pi over 4. So remember, the minus sign inside here is what's the standard equation, x minus c. So if your c value is positive, because you're moving to the right, the equation is actually negative. But if you're moving to the left, if you're shifting left, so negative 5 pi over 4, the equation reads x minus c, which is x minus negative 5 pi over 4, which would be x plus 5 pi over 4. So there you have it. There's sine, there's cosine. We're 6 minutes in. Let's get one more in. So 4b. Again, now this is going to be a little bit tighter, but I am going to identify that midline. And again, I'm going to start writing f of t equals. So our amplitude. Amplitude, let's see, well, two things. Here's our midline. Our midline is 2, and our peak is 2.5, valley 1.5. So that midline to the peak or valley, that is an amplitude of 1/2. The period of this graph, well, what we have, I'm going to look at the valleys, because I only have 2 valleys marked out. So this valley, I'm an x value of -2 to here. So that's a distance of 2. And then from the y-axis here, I have another distance of 2. So my overall from left to right, my period's 4. So 4 equals 2 pi over b. b is pi over 2. So amplitude, sine of period pi over 2, x minus c. So I'm going to leave that kind of blank for now. Our vertical shift, well, here's our midline. I'm drawing a sine curve, so the midline should be on the x-axis. But it's not. It's up by 2 units. So that is a plus 2. The phase shift, well, this is going to be one of those where the easiest and about the only place located is right here. This is the midline heading upwards, and we are shifted back by 1 unit. So x minus c is x minus -1, so x plus 1. So there you have it. Cosine, again, cosine's not going to change. F of t, not going to change in the amplitude. Not going to change in the period. This is where it will change, but look at this. The peak is, in fact, on the y-axis. We have no phase shift. So I'm just going to close that out. Now, I guess if you wanted to be proper, you could say x minus 0, and that shows the x minus c. We close that out, and we still have plus 2. There you go. Just over 9 minutes as we get in there. But that is question 4, A and B. So I will leave you with that and move on to the next video and the next problems.